Hey guys, welcome back to another one of my linked list tutorials. In the last tutorial, we saw how to create a linked list and then display it. Today, we'll be trying to cover these topics. That's counting the number of nodes, trying to sum each of the element, finding the maximum element in our list, and then displaying our list with recursion. All right. Okay, so let's just get started. Okay, so this is the code that we did last time. You can check it out in my linked list playlist. All right, so now I'm going to create a function which will count the number of nodes in my linked list. I'm going to create it as int so that I can return my variable which contains the number of elements. Okay, so I'm going to create count function, and then I'm going to, like I said in the last tutorial as well, I'm going to always pass my first. I'm going to call it p. So whenever I'm calling my function in my main, I'm going to always pass my first pointer. Okay, so in my count function, I want to create a variable c which will store the number of nodes in our linked list. All right, so now I'm going to create a loop. Okay, and here I'm going to type my condition, which I always said in the last tutorial as well. I'm going to call it p as long as p not equal to 0. Okay, so as long as the linked list exists, the code will run. Okay, as long as the node isn't empty, the code will keep running. Okay, so I believe I should make this null because 0 is a value. Okay, so now inside my count function, I want to do C++. So each time my loop runs, I want to increase it by 1, and then I want to then point my pointer to next. All right, that's it. Pretty simple, right? And then finally, I want to return C. Okay, so that's how this will work. So I am iterating over the entire list as long as there is some node value. So when the linked list finally points to nothing, at that time we know that our linked list has finished, and then we can stop our loop and then the count. So we will receive the count. All right, so I'm just going to try to display it here. Cout the counts, or let's call it length of the list is, and then maybe I want one backslash in here as well. It's always a good practice to leave some spaces. I'm going to give one here as well, and then here I'm going to call my count function. All right, so that's basically it. Okay, so now I'm going to, let's just run this first, and then we can go towards the other functions. Okay, so just give it a second. Yep, so as you can see, the count is 8. All right, so our linked list contains 8 elements. I'm just going to bring this back here. Okay, so we are done with the count function. Now let's move ahead to the sum function. Okay, so I want to create a function called sum. As I said, I want a node pointer, and then here I'm going to create a variable a. I'm going to give it 0. Okay, and here as well I'm going to use the same logic. I'm going to, as long as my list exists, I want to run this code. Okay, so now here I am going to do it like this: a is equal to a plus p dot data. Okay, so each time the loop runs, my data is added to the variable a, and now I'm going to point my list to further. Okay, here it is. So each time my loop runs, my linked list is pointing further, and then finally I'm going to get the data, the sum of the data which has been stored. Okay, so now I am going to return a. All right, that's it. Very simple. And now I'm just going to go ahead again and try to print this. /n the sum of elements of list is \n is, now I want to call my sum function, right? And I'm going to pass first. As I said, first is my head pointer, so whenever I'm running my linked list operations, I always want to pass first. You can check out my previous tutorial from this playlist so that you have a clear understanding of this. Okay, so now the sum function is done as well. Okay, so before running this one, let's just create the max function as well. So to find the maximum number, which is the greatest number in our linked list, basically. Okay, so let's just call it max. And here also I want to pass my node pointer. Okay, now in my max function, I want to create variable m, and for now I want to give it this value. It's called int minimum, basically. Okay, so I'm gonna go int minimum. So this is basically this kind of a smallest number. So as you can see, it goes to minus. That's a very big number. Okay, so now I'm just gonna make another loop. Okay, so here I can do it different as well. I'm just gonna go with p because it basically means the same thing, while p or while p not equal to null. Okay, so it's basically the same thing, it's your choice. Okay, so now I wanna create my main logic. Okay, so for in our loop we can go ahead like if p dot data is greater than m. So if my current value is greater than m, then I want to run this if statement. Then I'm just going to go with like p is equal to m is equal to p dot data. So I'm changing the value of m and then I'm setting it to the value of that data element. Okay, and then I'm gonna just change the value. I'm just gonna move forward. Okay, so that's basically the entire logic of the max function. Then I'm just going to ask it to return m. So that's basically my function completed. So what basically we are doing here, inside a while loop we are creating an if function, and then if my minimum value is basically smaller than the data element, then I'm going to change my minimum value as that data value. Okay, and then I'm going to move forward in my linked list, right? So that's basically it. So let's just call this again as well. I'm gonna call this again. So what was this? Max elements in list is max, and what we had to pass here, we had to pass here first, right? So that's basically done. Okay, you have to call it cout. Yep, so that's basically done here as well. Okay, let's just try to run this now. Okay, so as here in the output you can see we did the count, we now did the sum as well, and we have the maximum element, that is 87. Perfect. All right, so but you can see here the element is not in ascending or descending order. So like for example, it wouldn't work for just a specific condition, it will always work, right? Okay, so this is done. Okay, so now let's try to display our entire linked list, the same linked list, just using recursion. Okay, this is quite interesting, right? So let me just close these functions so we have a clear understanding. Yeah, I'm gonna create my display function here. Let's call it void because we don't have to return anything, and then I'm gonna call it display recursion. Alright, that's cool. And then I'm going to again pass my pointer. Okay, alright, so now we have a condition. So if as long as my pointer, my linked list exists, basically. So now here what I'm going to do is I'm going to try to print it. Okay, give it a space so it looks clear and simple. And now I want to print my p data, the data inside my node. Okay, so now here comes the main logic. Okay, now I'm going to pass my display recursion function again here. Okay, and then now what I'm going to pass here is p.next. Right, so what this basically does is this function, we call this function runs, we print the current data, we call our display recursion function again, and here we pass the value as p.next. So now our node is the next node. All right, so again this function runs, and then again the next data is printed, and then again this function runs, and then again this data is printed. So this goes on as long as this p, that's my node, isn't null. Okay, so once we don't satisfy this condition, we are going to end our function. Okay, so here's a cool trick. If you just want to print your list in the reverse order, all you have to do is just copy this display recursion line of code and just paste it above the cout line. Okay, so in recursion there's a concept called backtracking. So what it actually does is basically it will run the entire recursion loop, and then finally when it can't run no more, it will start backtracking. So once for example, suppose we cut this line and paste it here. So as you can see, the problem arises here because a lot of people have this doubt. Okay, so here we are calling the function before this statement is running. So what it means, so that it will always keep on running, and and this line would never run. Okay, so it's not like that. When this function is finally null, it does backtracking. What it basically does, it comes back and then runs the further lines of code. Then again it goes back another pointer, then it runs the further lines of code, and then since we are printing it here, it will print it in reverse. All right, so now normally how we did it, it will print the first element, second element, last element. Okay, now if we do it like this, what will happen is it will print the last element first, and then the second last, then again it will go backtracking and call it the third last and fourth last, and finally the first element, like that. All right, so this is a pretty cool trick to do. For now we can just display it normally, but all you have to do is interchange these lines in their order. All right, so that's basically done. And now I want to call my function here again, cout. All right, displaying list with recursion. Right, that's cool. Now okay, I want to just call my display recursion function, and I just want to pass first. All right, so now we are done with this as well. Okay, so now I'm just gonna try to run this code. Okay, so as you can see here, we have a list which we printed in the last tutorial. We have the count, that is 8. We have the total sum of elements, that's 223. We have the maximum elements in the list, and we have displayed our list using recursion. As you can see, the list is exactly the same. Instead, we are using the concept of recursion here. All right, so as you can see, both these display functions, this is the one we created last time, and this is the one we created just now. One is with recursion, and one is with not a recursion. Okay, so this is how it basically works. So that will be all for this tutorial. If you like this tutorial, please give it a like, share it with your friends, and subscribe to my channel. And then next time we'll probably seeing how to search a certain element in our linked list, and then maybe how to move a certain element in our linked list to the first position, and etc. It depends actually if people are watching, and if the series is turning out to be good and demanding, I'll make more of these tutorials. Okay, bye for now. I'll see you in the next tutorial. Bye bye.